So I think you people are ready with your case study. So any updates regarding the assignment or the work that we discussed? Let me try with first group. Group A. Is there any update from your part? Is there any member from first group, that is group 1 or group A? Anyone from second group? Hope I'm audible. Can you hear me? Am I audible?
Yes, it is audible.
I was
I am from group 2.
So there are.
I am from group 2 and
Okay. So what is the status from group 2?
it was just shared with you on your email ID. You can check by Sindhurani, I guess.
So what I'm expecting? I'm expecting either your entire group or some member of your group need to be there.
Yes, sir. Sindhurani will present.
So can you repeat once again who is being present?
Sindhurani.
So group 2 is ready. What about group 1? Anyone from group 1? Okay. Group 3. So what is the status of group 3? Group 3, what is your ages? Are you prepared? Okay. No line. What about group 4?
Yeah, we are ready, sir.
You're ready. Perfect. So we are going to start with group 2. After that, group 4 will do. Meanwhile, some other people will join. Then we'll check for group 1 and group 3. So from uh, group 2, second group, who is going to present? Group 2, who is going to present?
Am I audible?
Yes, audible.
Sindhu is having.
Hello?
Yeah.
Am I audible?
Yes, you are audible.
Yes, I will share my.
Okay, I'm making a presenter. Just a moment. Now, Siddharth, you are presenter. You can share. Your screen is visible. You just go to your the code file. Sindhu, your screen is visible.
Audible?
You're audible.
Yes, audible.
Okay, okay, sir.
Yeah, please. Participant can put the question in case you have any question you want to clarify anything. You are free to ask.
Okay, sir. Actually, on top of your code, we have left with few columns where the NAs were not removed. So first we have handled those NAs. Can I show everything, or wherever I have made changes, I can show?
I would say quickly it is good that you show everything what you are doing. Is there any other participant who want to present along with you?
Okay.
No, I'm checking. Is there any other participant who want to present along with you?
Whether we know anyone else who can support from my team. We all together work.
That's perfect. Now,
I will be there with you.
Yeah,
now please start.
I'm reading those files, and then I'm just handling the missing values.
Okay.
From here, we have handled the missing values from building class onwards, which were not done in the class. So, like, we have replaced with some of the most common ones. For example, okay.
We replace with modes of few variables.
So 1 second, I'm just running the missing values thing.
Okay.
Uh, some issue with 1 second. Yeah, just ran the queries for missing values. Replacing with the we have replaced with mode maximum.
Fine.
Just checking for the any missing values.
That's fine.
Only sales price is having missing values. Rest all columns are handled. I can show one example. For suppose if it is basement column, I have replaced with uh, zeros are coming around 930. So 108 with respect to this column. So I have replaced that missing column with 0 value. Whichever is I felt it is applicable, I have done. So after handling missing values, this was the numeric we have taken, numeric variables here.
And we are taking here numeric values so that we can use the correlation and VIF.
Yes, Chima. So with numeric values, we have checked for correlation. After in numeric values, we have around 37 columns.
That's fine.
In numeric table, we have 37 numeric variables. So we are taking the VIF of all these numeric variables.
What we have done, like for the correlation part, we found out that there are two values. They are highly correlated. One is grade living area and room grade cover grade. So they are having 0.8.
Yeah, this
I have explained there. And also that there is a first floor and the total basement area, that is 0.8. So what we have done, we have find out that they are very highly correlated. Along with that, we have also checked VIF. So which in VIF also we found out, you go over in VIF description, there is like two values which were highly multi-collinearity showing. In the console, if you go over.
yes, it is only displaying whichever threshold is less.
A little, if you can go above in the console. In the console, if you go above little, console.
Okay, 1 second. This is only the VIF.
No, you just go little above.
See.
Yeah.
Okay.
Yeah. After here you can see two variables from the 36 input variables have collinearity problem. So BS fin SF1 and first floor area. So we have removed these two. So these two are also coming falling into the correlation part. So we have removed these two. Also in the correlated value, we found out that we can remove grade living area and first floor area that is having VIF that is being shown as very high VIF or multilinearity problem is there.
Fine.
So we drop these columns.
So we have dropped these three. You have to library you have run.
Yes. No, sorry. Yeah, we have dropped these three columns and then we have verified for all the numeric variables again. So
We are just checking the IF is coming properly or not.
Yeah. So apart from these 34 columns, we don't have any other columns with VIF. So after this, we observed that in area columns there are negative values. So we have replaced those with positive values.
So how
like all the, if you can this
negative, how are you?
From the first side, when we are looking into the tables, we are arranging ascending, and then we found that there are negative values in the training set data only. Training data only, there was negative values for areas, but in the test data, all areas were positive. So, so areas should be positive as per business perspective. So we had made all the negative areas into positive.
Fine, it's good. Okay.
see here in the data there are negative values for all these columns.
using this ABS function, absolute function, to convert that, correct?
Yes.
Yes.
Okay.
So all these columns, around 5 columns, we convert to values. So which are is not for support. After transfer, so here is the transformation for these columns. We have used cube root, square root, and mostly we found like cube root is helpful, so we use cube root.
That's fine.
After transforming the data, just we have split into we have transformed the data of entire file. So we have split into train and test, built a model on a training data, and we have used the function which we have explained in the class. So based on the less than 0.05, we are not taking into the model. Uh, 17 columns. After room, we are taking these columns into our model. So again, data based on the training, we have used all. So post that we have split into training and test, and we have dropped the test column. We have built the model on training data, and this is the summary of the model. So we could see most of the columns are significant, and R square is coming around 0.7958. And then we have, based on this significance criteria, we have removed area from our code column here, and we build the model again. So the final R square we are getting around 0.79, and then this is the actual sales price, and the same 1459 as training data. This is the predicted sales price.
Okay.
And the difference we are taking into here. So this is the from training data.
That's fine.
And this is the difference.
After these all, we have also checked whether the linear regression which is done is following correctly or not. So there are assumptions, residual assumption by the test.
All right.
We have verified that done first, and we found that it is value is ranging between 1 and 2 and 3. So
between 1 and 3, so it is coming around 1.9.
That's fine.
1.9, yes.
Yeah.
Around 1.931. And then we have plotted the QQ plot. It is like residual distribution. Yeah.
So what is your observation here? Do you want to throw some light that what do you mean by this now? What is your understanding?
So like assumption, we assumpted like all the linear followed here, like the residuals are following normal distribution, and we have removed the multiple, and we are able to predict with higher R square at 0.79.
Okay.
If you run the plot, it will show the normal of the curve of the errors.
Okay.
So errors are coming like
All right. That's a good one. So is there any question from the class, from other audience? Do you want to say some question?
Can you please explain what is that BP test used for?
BP we used to check the heterogeneity
Okay.
that whether residual is following that heterogeneity is there in error.
Okay.
You can also check it through the graphs of it and run that BP test. Also can give you similar as whatever we are testing BP test. If you know, can give you similar in the graph. Errors are following heterogeneity or not.
Right.
Any other question?
I think let's do a virtual clapping for this team. It's a good one.
Any improvements from your side done?
In terms of improvement, going forward, when we learn more and more techniques, we talk about more and more processes. So what is happening here? I didn't explain about everything that we need to do because that will be too much. Yes, there are scope for improvement. That will if we start doing some deep dive onto some advanced technique, you will come to know. But for this test, this is a good one.
In my actually this lot of data are still not normally distributed. We couldn't distribute them properly. So I tried, but it was not helpful. So just wanted to like take a suggestion, like what else we can apply on those data.
Which all transformation? Did you apply any transformation?
Which one?
Like to make data normally distributed. So,
Yes.
so one way is to do the variable transformation, like log, exponential, and all. Okay.
Yes, we have tried everything.
You tried that.
There is still some data which are not normally.
So see, it's so happened that for this technique, if you apply, there are two things that we do. So let me share my screen, then I'll tell you the complete context. I think before I go to share my screen and tell you that how to improve or what can be done, I'm just checking at the team or the group. Is there any question which you want to ask or you want to verify?
Sir,
Even I faced the same challenge in normalize because I tried log and exponential, some missing values, especially INF is it's infinity. So I got so many infinities in my data and I have to proceed forward.
Okay, I will.
That I think you can use log of data plus one in the variable data.
A few suggestions from others, and many gave me reply to apply cube root, square root, and all. I few are done, but there are few other variables which have to normalize.
Even we faced for the same in INF for facing issue how to normalize.
Okay, I will. Though Abhishek explained that how to do it, but I will further explain.
Yeah.
Okay.
Yeah, please, sir. Yeah.
Sir,
Yeah.
sir, I have a doubt line backward elimination, sir. So for running the models, at each time we are getting different p values, sir. So one variable at a time by checking which is the maximum p value which is greater than 0.05, or reading the Broom model, like at a time we remove all the values which are greater than 0.05.
No, I would
So
say
what should be
that once we are running the model, and let's say you are getting 5 variables having p value greater than 0.05. Do not remove
Yes.
all in one go. Do not remove. Okay, remove one by one. Reason being is the p value that comes, that is there is something called interaction impact. So there may be possibility that the moment you, let's say 5 variables which are coming as not significant, the moment you drop 3, 2 will become significant. So do one by one. Do not drop all.
automate the process, like if you write a function like if else greater than 0. Like that, and run the model at a time. Or should if there are more variables, should we check all and delete one by one?
I would say for that there is something called step AIC. Okay, that step AIC performs certain eliminations and all. At this stage, I would suggest do one by one. Okay. But later on, we'll know that how to drop or how to write some loop or some function to perform this task in iterative.
How to find out outliers, sir? Like in the residual, some values the error is more than expected. So how to out, like how to identify those variables outliers?
Outlier, technically, we look into the independent variable. And what are the method to look for the outlier? Can you tell me that did I any method for outlier detection?
You didn't say, sir, just I'm asking. But in the just for linear regression, we should check for multicollinearity and outliers.
We need to look for outliers. We need to look for missing well treatment as well, multipolarity and other stuff. We need to look for the homosexuality. So everything that we need to check, because this is parametric test, it's technically follow normal distribution. And you have to do outlier treatment. If you do not do outlier treatment, your model will not be stable. Your best fit line change or
That is, we have. So your voice is breaking, so I don't know for me or for.
is my voice breaking for others as well?
Yes, it's
It's breaking.
Yes.
Just a moment. Let me change my connection. Now, how is it? Now, are you finding it proper?
It's better, sir.
So, what is it? You need to do outlier treatment. If there is any outlier in your data, then your best fit line won't be the proper one. So, that outlier treatment you need to do by using box plot. That's what we do. Was there any other question? I'm audible. Can you hear me?
Yes.
So the one question was regarding outlier. Yes, we need to do outlier treatment. Was there any other question? I'm not sure. Did I answer all his?
No.
I have doubt in the mainly backward elimination only, sir, because we use the Bro model and we eliminated all by using which are greater than 0.0. That's why I asked. Yes. That's it. Thank you, sir.
That's fine. Which one is the next group? Group number 4, do you want to present?
Hi, sir. So we were supposed to have the script and Vishal was supposed to present, but due to some emergency, he's not here. And the script is with him, and we tried opening the one he sent. It's not working. So we could probably work in the basic one. Is that fine?
So let's do one thing, then wait for him. Those who are not able to meet,
Okay.
they will. I think I
Because
suggest.
none of us are able to open the script he sent. Due to some emergency, he's not available today.
Okay, no worries. Then we are searching for some other group. So group number 1 or 3. Is
Okay.
anyone who is ready with the code?
Thank you.
Yeah, actually, I just wanted to know in which group I'm there because, yeah, last week I haven't joined the class and because my health was not good. So, did you send any mail regarding that?
On WhatsApp, I think message was circulated.
I'm not in the WhatsApp group. I've just messaged in this meeting.
Yeah,
Add me in that group.
in my Tasneem is not there. We will include her in from the next one. Okay, I added her in the. I added her contact. I will be adding into the WhatsApp. Okay.
Yeah, sure. Thank you.
Now from group
In which group I'm there? Any idea?
Can you say once again?
What's the stream?
In which group I'm there?
Actually, 2 and 3 are full. So 1 and 2 you can 1 and 3 you can pick anyone.
Okay, sure. Thank you so much.
1 and 3. I will share your details. Okay.
Yeah, sure. Yeah, message me please on WhatsApp.
Yeah, sure.
So now from group 1, 3, and 4, is there anyone who is ready with that code?
Sir, as I said, I don't think if my approach is correct, and I found there are so many missing, INF in my data, so it's incomplete. I don't know if I can share or not.
I will explain the way. In your group, is there someone else who attempted and got some output? You're in which group?
I am from group 1.
So from group 1, is there anyone who is having correct code which is functional and giving your output?
No.
Okay. Fine. So group 1 is done. Group
From group 1, do you have any other code?
So now,
Hello.
Yeah.
Yeah, Chinmay, I had a question. So when I was running the code sent by you, so basically we were supposed to convert it into character, right? So most of my variables, I didn't have to do that. It was already in character, so it was factored as per the recordings you sent. What could be the reason for that?
You are getting variable as character. Is that?
Yeah, so the one as per your recording, it was factors, which is actually logically supposed to be factors, but mine was saying as character.
You convert that as per factor into terms. It is all about system configuration and the kind of environment is there. So that is very
It could be probably because of that, right?
for that factor for some with that comes as cat. So you need to convert that as hash.
Okay. Thank you, Chinmay.
Let's do one thing. I think for the remaining three groups, you people can plan for tomorrow. I will be giving you some idea that how to like the first one is in science wherein you are getting infinity value. That is INF. So how to treat that? I'm going to explain the process, and you can spend some more time and let's plan a book present tomorrow if possible. Is that fine for the remaining three groups?
Sure, sir. No issues.
Okay. Now I am going to share my screen and wanted to showcase something which I taught in today's morning class. So I thought it is worth sharing with you as well. So let me know what my screen is. Is it up? Is my screen visible?
Yes.
Yes.
Yeah.
Yes.
Okay. Now, these are the moment I'm talking about EDA, that is exploratory data analysis, plus I would say plus DP, that is data preparation. So what are the steps that those are involved into EDA plus DP, that is data preparation. So I'm having both EDA and data preparation both together to make it more meaningful. Now, anytime if you realize that my voice is deteriorating or it is coming feeble, let me know. Reason being, I think in Bangalore it is raining heavily. I'm not sure that how the connectivity would be going forward. Now, the first step into EDA or data preparation is identification of the variables and the data type. That means you are reading the data and you try to know or try to understand that which all variables are coming as numeric and which all variables are coming as non-numeric. That is factor or character, whatever. This is the first step. The moment we read the data, we need to run STR structure. Fine. So this is talking about the STR function that run the structure. Then the second step is to analyze the basic metrics, wherein we get some basic information about the data. So can you tell me that which function helps us to get a basic statistical matrix? Yeah, which function helps us to get the basic statistics?
Summary.
Summary. Now, after that, in the third step, we do something called non-graphical univariate analysis, where we calculate something like standard deviation variance Q1, Q3, IQR. That's what we try to do. That is a univariate analysis. So we discuss about univariate, multivariate, what all comes there. So that is the next task that we need to do. After that, it is coming the graphical univariate analysis, wherein we do like box plot or normality plot to understand that how your data is looking like. So here it gives you idea that is there any outlier, your data is not normally distributed, or how the things are. So you get some basic idea from here. Once that is done, so in fifth step we do bivariate analysis, where we run some correlation plot or the pair plot to understand that how variables are correlated to each other. Is there any kind of high correlation among the independent variable? If that is done, the moment you find some in bivariate analysis something is happening, then we need to do variable transformation. In variable transformation, you can try log, you can try exponential, you can try inverse, etc. So you can try some of the, or I would say you can normalize, you can standardize. So you can try these all methods. And the objective is to either bring on the lower scale or to make the data less volatile. Volatile, that means ups and downs. So the moment you do the variable transformation, your data start looking good. I'm giving one example here. So let's say that you are having some data points here. These are the 5 data points. In between, there is one missing value. The third record is missing. Now, one way is just calculate average of these all 5. Average is coming like 222, and replace this missing value by this 222. That is one method. Other method is do some transformation. So here I'm doing log transformation. I simply did log. Okay. Now let me answer one question of infinity. That what is happening. So I'm just going to consider my first value is 0, and then I'm passing this function here as well. Did you see what happened? It is saying that something that is not a number. So in that case, what is suggested that when you do a log transformation, add very small number like 0.001. That if you add a very small number, it will not give you infinity. So the moment you are writing a log function, it is suggested to add a very small number. That number will not impact your variable distribution, but yes, that will save you from getting infinity. I hope that is clear.
Yes, sir.
So that is the way. Even in the infinity inverse transformation, let's say that your value is coming as 0, and you are going to calculate inverse transformation, like it is equal to 1 divided by this value. See here, it is spending towards the same issue. Here it is suggested to add a very small value, like plus 0.001. A small value is not going to impact anything. You're getting it? Add something very small. Not put that as a 0. The moment you're doing some inverse transformation, etc. So it's your call. You need to find that how big or how small number is. Like in this case, if I add 1, let's see what is happening. This is 0. If I'm adding 1, it is good for me to pass 1. Here, passing 0.001 is detrimental for me. So that 0.001 may be good for log transformation, but that is not good for inverse transformation. Getting that? So you need to figure out at the moment you are adding constant, how that constant is impacting your value. But yes, it is always a good practice to add a constant, I won't say small, add a constant which help you to not get the infinity value. I hope that is clear. Lavanya, for your case, your infinity issue is solved?
Yeah, yes, sir. Actually, I have searched it on Google and I also saw this method. I tried for few weeks, but I didn't know if that was a correct approach. Yeah.
This is the only approach I will say.
Yeah, but is that okay if the value is getting bigger value, few values were small? That will not make any difference to the data during the normalization.
That's why I'm suggesting you, in the case of log, add a small value. If you are adding a small value, that will not impact that much.
Okay.
Technically, it does not distort your distribution. So your distribution will remain in the same shape. So it does not change shape. Okay. Now, let's say I'm doing log transformation for this 5 values. I'm getting this log value. Now, if I calculate average is coming at 3. So now you tell me, replacing this missing value, log transform missing value by 3 is better than replacing the original value by 222. Reason being, if you check the first instance value or missing value is coming as 222, the upper and lower both values are smaller than this. But in the transformed one, that is not happening. So you need to be very careful while if you find that the values are not properly, so in that case you need to do some transformation and do the imputation post transformation. I hope you are getting the message. Is that clear to everyone? Now, then coming back to variable transformation, I explained log, exponential, inverse, normalized, standardized, whatever you want to do. After that, you do the missing value treatment. Now, once that missing value treatment is done, then it is suggested to do outlier treatment. Now, the question is, Should we do outlier treatment first and then do missing value treatment, or we should do missing value treatment first and then do the outlier treatment? My question is, from step number 7 and 8, you can swipe. That means you can do outlier treatment first, missing treatment later. But if you are doing variable transformation, in that case, it is suggested to do first missing value and then outlier treatment. Because once you do transformation in your data, you won't have some influential cases. Some big value won't be there. So it is your call. You can swipe at the place of step 7, you can do step 8, and at the place of step 8, you can do 7. So 7 and 8 both are like interchangeable. You can swipe it. I hope that is fine.
If we do the variable transformation before missing value or outlier treatment, will it not be impacted because the variable transformation will change the value, and then we are doing missing value treatment. So it is fine, or before also we can do.
Yes, it is fine. I would suggest that it is always ideal. What all steps I wrote, those are ideal scenarios. Getting it? You are free.
Okay.
You are free
Right.
any step depending on your understanding. Reason being, in analytics, nothing is wrong provided you have support or you have kind of justification that why you are doing it. That is one thing. You must have justification, and second, your model must be optimal one.
Okay. Then just for example, in this case, we found that an area was negative with 10 values. Then this step has to be performed before variable transformation, because negative will if we do transformation of the negative value, it will change the value at all. Lot of value, because we can make it positive and then do transformation.
So that you will come the moment you do the basic metrics. In basic metrics, you will only come to know. Reason being that display your minimum value. So the moment you are getting minimum value is going negative, you need to treat that after step number 2 only.
Right.
Fine?
Yes, F will be coming into fifth number correlation, and then we also will be coming in that.
Yes, there are. I mean, there are many steps. The moment we are talking about this bivariate or univariate analysis, you are understanding those everything. That's how it is going to be.
Right.
So those VIF, everything, those are mathematical procedures. These are the steps.
Right.
Now, then coming to that is done. Then coming to correlation analysis. So here in correlation analysis, I wanted to explain you something. Okay. Let's take the example of housing data itself. I have Y, that is sales price. I have X1, which is house size, and I have X2, which is number of bedrooms. The moment I am running correlation between X1 and X2, I am getting my correlation is coming as 0.79. If I am running correlation between X1 and Y, that is between independent variable, I am getting 0.85. If I am running correlation between X2 and Y, I am getting my correlation is coming as 0.72. Okay. Now you tell me, out of these all three correlations, which one is good, which one is bad?
X1 and Y is
X1 and Y, this is good. Okay.
good, and X1 and X2 is bad.
Okay. And the second X2 and Y is also good because we are looking for high correlation. Now, question comes, X1 and X2 are highly correlated. So we cannot have both variables into the model. I need to drop one variable. Okay, either I drop X1 or I drop
X2. Right. Because Y is directly more proportional with X1.
Right. So you can see the method. We come to know that your X1 is highly correlated with Y with respect to X2. So technically, we should drop X2. So if the question is coming for dropping, we need to drop X2, not the X1. This is how we sell. Getting that? Now, coming to the step here. So that comes under the dimension reduction. So in dimension reduction, we have this kind of we drop the variables. One scenario is those variables which are highly correlated, that is multiple, we need to drop that. That is one thing. There are other methods as well, which we'll talk later, like LDA, PCA, factor analysis, that will come later. So we'll talk about both methods as well, that how to reduce the dimensions, right? Because there is a thing that called curse of dimensionality. So if your model is having more dimensions, that is cursed. So from that perspective, we need to reduce the dimensions. That means we need to drop the variable. And I'm just sharing my experience. We had a model with a high dimension of the variable. Moment drop majority of the variables and prepared with the handful some selected variables, we are still able to maintain a similar accuracy. So there is no guarantee that more variable will give you high accuracy. So it is always suggested to consider the lesser number of variable when if you are able to maintain the model accuracy. Now,
for the ninth one, I am having one question. If we are doing correlation analysis, we can also do VIF together and then check which variable we can drop.
now there are two things. First is you have realized that again correlation is VIF will tell you that which all variables are correlated where the VIF value is high. So that is supposed to get dropped. But there are certain limitations with VIF. That's what we check. In linear regression, when I was fully dependent on VIF, I dropped my most important variable, that is sale price. Do you remember that case?
Yes.
So it is not a kind of error proof. It is good to run VIF along with correlation and then make a decision based on your understanding.
This is both of them.
Yes.
Okay. And also VIF, you are saying as a factor, the value we have to adjust according to us, because sometimes 10 value also will be better because that variable might be important.
Right. So solely in any of the data science project, we never solely depend on the machine. What machine is saying, we are doing that. There is a kind of human interface wherein we add those interface or we add those value, which ultimately lead us or give us better result. So yes, you can run correlation. Like if you run the VIF like between X1 and X2, I'm not sure VIF will exactly tell you to drop X2 or VIF may also say you to drop X1.
Yes, gives VIF value plus it also gives high multi-collinear variables.
Right.
Both it gives.
Correct. So consider both and then drop it. Make your judgment.
Yes. And in the 10th one, I have like question like factor analysis. Before actually in this data property price prediction, there were a lot of variables in which there were only three 0, 1, 2, only three values were there, and that was repeating. So I thought of converting into factor, but my result was getting affected.
So that is this is
so
this is factor analysis has nothing to do with factor variable. This is a different type of analysis.
Okay, for this one, how to treat not this one factor analysis. I'm just talking to converting the variable which having only three values that is repeating. We should convert into factor, or is it okay to keep it numerical?
I would say in that case, converting that as a factor will give you a better interpretation with respect to putting that as a number.
Okay, because I did it and then I removed it because I thought it is affecting the accuracy.
No, but if you talk from the interpretation perspective, if the variable is having only three labels, let's say that in the marks 50%, 20%, 100%. It are only three numbers, though this is looking like a number, but for me this is not number, this is category. So it is good to take that as a factor.
Linear regression takes factor also into consideration.
Yes, of course. That's what I learned.
Okay.
But if you remember one example wherein I did it, I explained that how one not coding or dummification is happening. So yes, that we consider.
Correct. The 11th one, I just wanted to check for this property price prediction. There is like construction year and the year sold. So if I difference I take and make a new feature.
Yes, that's what I think. Similar, we did something also. I on the numeric on the time stamp, I created two variables in your initial housing price.
We can drop the earlier two one, construction and the year sold. We can drop those two variables.
It is not necessary that we need to drop. Reason being, those variables has its standalone impact. And the moment you are considering two variables and calculating difference, that may give you a different information. So do not drop that one. It is not suggested to drop the initial variable.
So we are increasing one variable. So actually, we have to reduce as much as we can.
Fine. So on the removal part, so again, if you are removing on the basis of significance or on the basis of business, then that is fine. As far as theory is concerned, so if you are calculating a third variable, variable, you may include the initial two variable, you can exclude as well. But no one says, nowhere it's written or nowhere it suggests that we have to drop it. That is not the scenario. It's your call.
Right. Okay.
So these 11 steps, I would say, there may be some more sub-steps in between, like in the correlation, you can add some VIF. So there may be some more sub-steps, but probably these are the 11 steps that we follow in the ED or data preparation process.
So Chinmay, like feature, if it is created, we are actually doing it before correlation analysis. We can do correlation before that, so that we can have good correlation and then check.
Technically, it is suggested feature creation and all is supposed to be the kind of closure stage. That means you're about to finish your what I say this data processing. You are free. You are through that. These are the variables I'm going to use, and on the basis of those variables, you are going to create some features. Again, this is not a kind of very hard and fast. And in talking about the correlation, maybe you are creating a feature before correlation analysis, and then you are checking that is this feature anyhow related with any of the variable. So you can do before step 8 as well. I think that.
Right.
But technical is your kind of the last stage should be feature creation. Now you are creating some feature because now you are through. These are the variables I'm going to use. Using those variables, you are going to create some feature.
My only concern was that if it is this new feature creation is having high multi-collinearity, then it will not be giving correct result.
I would say one thing, that if you are creating feature in a technical way, that is not bound to have collinear with any of the variable. I'm giving an example here. It's all depends on how are you doing. See this data. This data is like some of your logistic regression. No worries. It may be linear regression as well. One variable is age, other variable is gender. Okay. What I'm suggesting a variable called difference of age with average. Like for male, like for entire age variable, your average is coming at 35.5. So what I suggested, take the difference of average with the actual age and calculate this. Look here. The scholar is saying that C2 minus 35.5, which is what the average of the overall age segment is. Okay. And you are calculating this value. This technically should not be highly correlated with age. This should not be. That's one thing. Second, you can calculate a difference. Like for male, you can calculate what is the age of the male participant, average age of the male participant, and what is the average age of the female participant. That's what I wrote. This is for male and this is for female. And you are going to calculate difference underscore gender underscore average. That means you are calculating difference of age from its gender age. Like in this case, look at what's happening. I'm calculating difference from the male average, not the overall. So if you are calculating something technically, that won't be multicollinear, that won't be correlated.
Okay.
Get you can always check equality even after feature creation as well. You are free to do that.
Right.
So these are the steps I would suggest to that will be top of your mind. You can add some more and more steps. Even you can drop certain steps, like the fourth one, which I highlighted in yellow color. This is not mandatory that you need to have the graphical univariate analysis. If you want to drop, you drop it. Because graph is more for illustration to others. But yes, it's good to run it.
Chinmay, sometimes we get very high accuracy with significant variables like more than 99%. And if we also we have another R square value which is much more greater than the previous one, but having combination of like 95% to 100 percentile. So which one to take with lower significant value, a little higher, very higher R square value, or the R square with the all with 99 percentile more significant value?
For that, I'll tell you. I don't know where did I write it. Now, first of all, there should not be any confusion that are we going to consider 95% or 99%. That should not be confused. Before you start the analysis, you must have your problem statement written in black and white. In problem statement, it is clearly written that you are going to consider at 95%, 99% or 99.9%. So first, you need to decide beforehand you start any kind of analysis. Getting it? If you are looking at 95% confidence, anything which is any variable information which is dot, single star, double star, triple star, you need to consider all. So it depends at what level of confidence you are working.
Correct.
Fine. So with that, what I'm expecting that those who have, I think, 3 groups, you can plan for tomorrow, spend some time, and even my plan is that going forward, any case study presentation is going to happen on Sunday, not on Saturday, because what happens especially for working professional, they may not get time in weekdays. I think probably on Saturday they can spend some time, and Sunday they can present it. So this idea came from today's morning batch, when people suggested that no, Saturday is a bit tough. 5 days we are working, and Saturday, if something is coming to present, it is making things slightly difficult. So going forward, this entire presentation will happen on Sunday only. I hope that seems like plan.
Yeah, that is. But for me, to even Saturday is working like first, third, and fifth Saturday. But still, it is manageable. Saturday is slightly less work.
Okay, but we are planning for Sunday. So going forward, all case study demonstration from your end will happen on Sunday only.
Great.
Now,
regarding the property price prediction, I found out that one value like construction year of the garage was like 1951, for example, and the building was constructed 1952. So it is like how come before the garage has been constructed? So we have to change that value.
That's what we are expecting. That as a subject matter expert, you need to investigate. You need to find yes.
The construction of the building will happen first anyway, from the business perspective also, and for the logic also. And the garage will be after that only. But by one value was having that difference. So for one value should will have an impact in the model success, or is it okay if we can ignore one value out of those 2000 values? Only one value is having like that.
I think that will not have that much of impact, But you need to know the reason, that in case if it so happens that this is something which you're getting from unknown source. If you're going to get data from known source and you are getting this scenario, you need to discuss with the stakeholder that why it is so.
Right.
I think Araf, you were saying something.
Nothing, sir.
Now,
So one question from me.
yeah, tell me.
Yeah, ear fields are not normally distributed. Should we transform ear fields also for suppose construction ear? Do we need to do any transformation on ear fields?
Not for the timestamp, normally it is not required. In data science, there are three types of variable technically. One is numeric, second is character, that is factor, and third is the time series. So for time series, the normally it is not required. So do not do anything at this stage. When we talk about the time series problem, I will explain that how to read time series well.
Okay. So here we can keep it either.
Yes, just keep it like that only.
Okay, because we were not able to like normalize the data for that.
Never do that. Never normalize any time series value.
Okay, sure.
Otherwise, you will start getting some unexpected result. So time series has a different behavior. I will explain.
Right.
Moment I land to that time series method like Arima or Four Winters, I will explain that how to read or how to make some interpretation.
Right.
Now, when I am moving on this logistic regression part, I'm not sure that how many slides this is in the previous class. Do you have any idea about slides? I think I was explaining about that Excel spreadsheet, correct? That's what I was doing about to calculate that log likelihood value.
Right.
Okay, let me land to the same Excel. Because there is some more information I wanted to share. Wait, I don't know. Where is it? Oh, it is here. So I think in previous class we discussed about this log likelihood. Correct? We discussed about this.
Only the first part.
We did the first, correct?
Yeah, this part we did. Second part we didn't.
So now I'm just going to recap that what all we discussed in the previous class. So let me open this. Wow, this one what will give you a scary look. Wait. This was for LDA, which I was explaining in the previous class. So there are lots of mathematics. I do not want to drop it. Okay. Now, I'm just going to recap that what all discussion we had in the previous class, and that talks about in terms of equation. We discussed that your probability is calculated as 1 divided by 1 plus e to the power beta naught plus beta 1 x. And this is going to be a negative sign. So what we discuss about the equation? Fine. Now, then for error for as evaluation, I suggested that for evaluation, we use something called LL, that is log likelihood. And this log likelihood is calculated as like y log py plus 1 minus y log 1 minus py. That's what the value we discuss. And as I suggested that our objective is to, this is also known as maximum log likelihood. People also call it maximum likelihood. But this function is maximum log likelihood. That means the way we run the model, we try to maximize this value. That's what our objective is. In linear regression, the error term we use to minimize, but log likelihood value is maximized. That's what our task is. Now, are the value of log likelihood better for the model? So this term, maximum log likelihood coming from there only. In linear regression, you remember I talk about LEAST, least square estimation. So there I was talking about least. That means we need to reduce. But here I am talking about maximum. That means in this technique, we need to maximize it. That means we need to get that value. I hope this understanding is clear.
Yes.
Yes.
From there, I am moving to that Excel. And if you remember this first Excel, the first spreadsheet, first part here, there are two instances which are wrong. So actually, case number 6 is one that is a bad customer, but my model is saying good customer. And case number 7 is technically a bad, sorry, case number 8, which is technically a good customer, my model is saying as a bad customer. So there are two wrong in this data, in this model. This model is producing two wrong results. Correct? Is that fine?
Yes. Yes.
And in that, from that perspective, we calculated this log likelihood value. And I saw that my log likelihood value is coming as minus 1.68. Then I suggested to calculate something called deviance. And deviance is calculated like minus 2 log likelihood. And we convert this negative as a positive number. This part is clear?
Yes. Can you go up once?
Up.
Yeah. Okay. Yes. We're good to go.
Now, then let's say that we did some tweaking for the same data and we got a different model. And this model is producing these probabilities. And based on this probability, I converted that into the class, prediction class. Let me get the font. I hope it may not be visible properly. So second model is giving me some predicted probability. Don't say that how this model is doing. Reason being, we'll talk later that how to optimize. But it says the second model, wherein we drop some variable like transaction count. I drop transaction count. In previous model, the transaction count was there. Here I'm dropping. And I'm dropping, I'm getting a new, there's a new model, and this new model is giving a different probability. And now I'm converting that as a class. So look here, in this case, this all my predicted class are exactly matching with actual. Like case number 1, my model is saying bad customer, that is good. Case number 6, my model is saying bad customer, good. Case number 7, model is saying bad customer, and this is bad customer. So I'm getting back all 10 predictions which my model is doing. Those are the correct predictions. Is that clear? Till here, are people with me?
Yes.
Now,
Yes, thank you.
then we are going to calculate the same log likelihood value. So the way I did in the past, log py, log 1 minus py, then multiply y with log py, 1 minus y with py. I perform the same task. And after that, I am summing up the value. So look at, when I sum up value, I am getting log likelihood as minus 1.38. Earlier log likelihood value was minus 1.68. Now you tell me between minus 1.68 and between minus 1.38, which was bigger?
Minus 1.3.
Minus 1.38 is bigger.
1.38. Yes.
This is why we call it maximum log likelihood. So if you have two values for log likelihood, you need to select one which is having the maximum value, that is the highest value. Getting that? So out of these two, we are getting that the second has high value with respect to the first one. Getting it? So according to model, we should go by the second model, wherein your log likelihood value is higher. And we saw that this model is almost 100% accurate. So now you are getting sense that why I am talking about the maximum log likelihood. Is that clear? For your good model, your log likelihood value is higher. Then we are converting that into deviance and we are getting this deviance value. Now, the question comes here that the moment there are multiple packages like R, Python, SAS, all has its own framework to give you the value. There are certain packages which give you this deviance value. Fine. There are certain, I would say, the tools wherein you get this log likelihood directly. If you are getting the deviance value, so in that case, lower the deviance, good for the model. If you are considering log likelihood value, higher the value of log likelihood, better for the model. Again, deviance and log likelihood both are opposed to each other.
Chinmay, your voice is breaking sometimes.
It is breaking for others as well.
Yeah, it is.
Wait,
It's not very smooth sometimes.
sometimes it is breaking. Oh, wait, I think. Oh, no, I think this Airtel signal is better than DC signal. Okay. So what I said, did you people understand or I need to repeat it?
Repeat.
I suggested that first I said that higher the value of log likelihood, better for the model. So if you compare the previous log likelihood value and the next log likelihood value, you are getting that the second value is having the higher log likelihood. Is that part clear?
Yeah.
Okay. Then I'm saying that it all depends that are you trying to look the log likelihood value or you're looking at the deviance value. If you are looking for the deviance, then you need to find the lower deviance. So be careful, lower deviance is good for model, but high log likelihood is good for model. So it is your call that what is going to be your evaluation. Which metrics you are looking into the software, like R or SAS or Python, whatever it is producing, which metrics you are getting. If you are getting log likelihood, then set the model which is having a lower log likelihood. Sorry, the high log likelihood. If you are considering the deviance, then select the model which is having the lower deviance. I hope that part is clear.
Yes.
Now, it so happens that in R or Python, usually we get deviance information. So, from our perspective, we need to look for a model which is having the lower deviance. That's what our plan of action is going to be. Now, from deviance, what happened? There is another information that is known as AIC. AIC here I wrote in line number 61. And the full form of AIC is a key information criteria. Okay. Now, let me go back to my notepad here. I suggested that we have something called log likelihood. Log likelihood. And for deviance is calculated like -2 into log likelihood. That's how deviance is calculated. That's what we saw. Then there's another stuff which is called AIC. And that's what AIC is given here. So the way it is calculated is calculated like -2 log likelihood plus 2k. Now the question is, what is k here? Here the k is talking about number of variables. Number of variables. Number of variables that you are considering in the model, that is what the meaning of k is. And though this AIC is calculated by help of deviance only, in deviance we are adding this 2k. So here also lower value of deviance, lower value of AC. I hope you are getting what I'm saying.
Okay, this is the number of variables. Yes. 2 variables. Is that 2k?
2k is not 2 variables. Let's say that in your model, if I consider the housing prediction, so we have house size, number of bathroom, and rest size, 4 variables. So in that case, this k is going to be 4.
Okay.
There is number of variables in your model. That's fine.
Could you please tell us what is it?
What is?
What does it stand for?
K.
AIC.
That's AIC stands for a key information criteria. That's what I here it is written in line number 59. It is AIC that is talking about the key information criteria. Fine. Now, here,
can you repeat on why you calculated it?
now I'll tell you. Why? First of all, this deviance calculation is clear. You're clear about this deviance? Am I audible? Can you hear me?
Yeah, it's clear.
Now, deviance is clear. So it's not that, as I suggested, your model is susceptible or kind of your output is a function that how many variables are there in the model. So let's say that you are developing two models, model 1 and model 2, and both the models are having let's say 1000 records. Model 1 is developed using 50 variables, and model 2 is developed using let's say 10 variables. Getting it? So in that case, it is not a kind of apple to comparison, because your first model is developed using 50 variables, second model is developed only using 10 variables. So in that case, to measure the impact, that how the number of variables are impacting your model, Kiki suggested that in deviance, let's add this number of independent variables in the model. And higher the value of k, let's say like this case, you will be getting interpretation. Let's say -2 log likelihood. -2 likelihood value is let's say 100, and for the first model, I'm saying 2 multiply 50. So this is going to be 200. But in second model, it is going to be 100 plus 2 multiply 10. So this is going to be 120. Bring that. And if that is scenario, then it's better to go by the second model, not with the first model. Reason being, we are looking for called the lower AIC value.
Chinmay, the -2 LL will be a negative, right?
No, -2 log likelihood will be a positive number. Your log likelihood negative. The moment you are multiplying -2, that becomes as a positive. That converts as a positive.
Okay.
So your log likelihood is a negative number. In order to make that positive, we multiply with -2. So now you are getting the reason that why, that how it is impacted. If this is the scenario, we have two models. Essentially, we would like to go by the second model, not with the first model. Is that fine?
So, Chinmay, a good model would have high LL, low deviance, and low AIC, right?
A good model will have, yes, high log likelihood, low deviance, and low AIC. Correct.
And low.
Davis is also low.
Yes.
Yes.
But in the package R Python, you do not get all together. You will usually pick only AIC value. So if AIC is high, that
okay.
yes, if AIC is high, that means your deviance is also high, and that means your log likelihood is low. So it is, I think it's a reverse. So if AIC is low, your deviance is low, and your log likelihood is high. So you can, because everything is correlated, everything is linked to each other. Clear?
Okay, we can infer the other AIC. Okay.
So we only get AC. When I run the model in R, you will be getting, we only get the AC. That is fine. Now, here we understood the impact of number of variables. Take the second scenario, another scenario, wherein, let me, I'm saying scenario number 2, wherein model 1, I am saying model 1 is developed using 10,000 records and let's say 50 variables, wherein model 2 is developed on, let's say, 5,000 records and let's say 10 variables. So your number of variables and number of records both are not same. So people suggested that fine, AI answered the number of variables into the model, but who is going to answer number of records into the model? Because your model also has impact of records, that means observations. Getting that? So from that perspective, another thing, and that we call BC.
Chinmay, can you repeat this? What you just explained.
I will do. In the first AIC, we saw that AIC is able to answer number of variables into the model. Like first model has 50 variables, second model has 10 variables. Getting that? But what if two models are developed on different number of variables, like 50 variable in first model, 10 variable in second model? At the same time, number of records are not also the same. Like in first instance, your first model has number of records and strings of records. Second model has this number of records, that observations. So first model is developed on 10,000 observations. Second model is developed on 5,000 observations only. Fine. So in that case, and we know that model has impact on the number of records. How many records are there into the model? So people suggested that let's incorporate the impact of number of observations also into the accuracy. And from that perspective, this BIC came. That is, BIC is Bayesian information criteria. BAIESIN, Bayesian information criteria. That's fine. Now, what happened in BIC? It is similar to AIC. So let me write both the equations here. So the way we saw, your AIC is written like minus 2 log likelihood plus 2k, but BIC is written as minus 2 log likelihood plus 2k into log of n. Let me check 2k log of n. Yes, 2k log of n is correct. That is how it is developed. Wherein this n is the number of records. So that is observations. That many observations are there into the model. And k is the number of variables. How many variables are there in the model? Get that? I hope people understood the difference between AIC and AIC. Is that fine?
Yeah.
But technically, it's so happen that BIC is not available in any of the, I would say, modern FAs. This is not available. BIC information you can get on Mac or Octave, but AIC is available for us. So we usually get AIC in Python. So in our Python, you can get the value of AIC. But it's good to know that what is BIC. People sometimes ask in technical round, so it will be sufficient enough to give you an answer. You can manually calculate the value of BIC while adding AIC plus log n. If you do, you will be getting BIC. Fine. That is what given here. That's how BIC is calculated. Like BIC is minus 2 log likelihood plus 2 log n. And then n is number of cases into the data, and number of record, and k is number of independent variables. That's fine.
इसमें डाल देते हैं.
Are you saying something?
No, sorry.
Okay. Now, next, I'm going to explain. So, we discussed about three things here. In fact, four things. Your log likelihood, variance, AIC, and BIC. You need to remember because people ask these questions in technical. Next, the one I'm going to talk that is equally important. This is slightly tedious, but not difficult. So the same one, the same data I'm using here. I say that these are the 10 records I have, and this is the actual label of customer. That customer is good, which customer is bad. And I have information like age, gender, transactions, time stamps, something. And these are my predicted probability. And from that predicted probability, I convert that into class 0 and 1, depending, taking cutoff as 0.5. So any value is more than 0.5, that is going in favor of 1, else it is going in favor of 0. That's what I did. And let's say this is my best model. So if you see here, this is the same model no, this is not the same model. Yeah, this is my first model wherein we had two wrong cases. That's fine. So let's take our what I say the first model because that will give you better leverage to understand. If I take the best model, there are some parameters which won't appear here in that case. You won't be able to get that way. So by design, I put that the first model which was not that much of good. And what I did, I prepared a matrix here. You need to listen very carefully. It is slightly, I would say, complicated, but not that much difficult. So there are 10 cases I have, from case 1 to case 10. What I did, I selected case number 1, 6, and 7 because these cases are having flag as 1, 6, and 7. So I wrote 1, 6, and 7 as row of this colored area. So see here in the row, I wrote 1, 6, 7. I think this part is clear.
Yes.
Now, then what I did, the remaining other, which are like 0, 2, 3, 4, 5, 8, 9, I wrote that in rows. Yes, column, sorry. In column, I wrote that. So what I did, the actual 1 cases are written in row and actual 0 cases are written in column. I think till here you are clear.
Yes, sir.
With the last part.
I said that from the actual label, all the instances which are 1 I am writing in row. And all the cases which are actually 0, like 2, 3, 4, 5, 8, 9, and 10,
Okay.
writing in the column. Is clear?
Okay.
Till here it was too easy. Now the complication going to start. Then if I come on this cell where my currently cursor is, this is comparing 1 with 2. So if you see here, this is comparison of 1 with 2. So what I need to do, I need to check here in a prediction. I need to compare the predicted value of case 1 and case 2. Fine. If the predicted value of case 1 is greater than the predicted value of case 2, then it is going to be green. Again, I'm reiterating. I'm comparing case 1 with case 2. And for that comparison, I'm looking at the predicted value. If the predicted value of case 1, for case 1 predicted value is 0.6, and for case 2 predicted value is 0.1, if the predicted value of case 1 is higher than the predicted value of case 2, then this cell is going to be a green color. And my arrow is going up. This is clear?
Yes.
We have close to 32 participants. I'm not sure. Are you people able to understand what I explained for case 1 and 2 comparison?
Yeah. Yes, sir.
Okay. Same I'm going to, if I come on this cell, second cell, wherein 1 and 3 being compared, can you check the same is happening? Is the predicted probability of 1 is higher than the predicted probability of 3? Is it?
Yes.
This is also green. So in this row, if you see, I'm comparing the predicted probability of case 1 with all other predicted probabilities. And we are getting that predicted probability of 1 is higher than all other cases. So it is everything is going to be green when we are comparing with case number 1. That is fine.
Yes.
Then I'm going to line number 2, case number 6. So I'm comparing case number 6 with case number 2. Similar way, the way I did for 1 and 2, the same I'm doing for case number 2, case number 6 and 2. And till case number 5, everything is fine. Saying something? Ashish?
I could not hear you. Ashish, could you mute yourself, please?
I'm expecting people need to be respectful for others. In case you are getting some call or you want to talk to someone, mute yourself. Now, so the same task I did for case number 6 with other cases. And see what happened. I compare 6 with 2, it is fine. So 6 has 0.4 probability and 2 has 0.1. This is going fine. The moment I'm going to compare 6 with 8, let's see what is happening. The predicted probability for 6 is 0.44, but for predicted probability for case 8 is 0.55. So the prediction of 6 is not more than prediction of 8. That's clear?
Yes.
So in that case, I'm coloring that red and see my arrow is come down. Fine. Now, and now for 9 and 10, it's correct. Then I'm going to compare with case number 7 to all other cases. Everything is fine except case number 8. In case number 8, if you see the predicted probability of 7 and 8, both are same. So in that case, I'm putting that yellow and my arrow is going like horizontal. It's going parallel. So we have 3 colors, green, red, and yellow. And the 3 colors are talking about 3 different behaviors. The green one in statistical term is known as concordant, that is concordant pair. The red one is known as discordant, and the yellow one is known as tight. So this is the technical name for these 3 behaviors. Concordant, that is green. Concordant is good for the model. Discordant, that is red, which is bad for the model. And tight, yellow, which is neither good neither bad.
So your voice is breaking, sir.
Breaking. Wait. Now, is it fine or still not coming proper?
Your voice is breaking and breaking sometimes. Not always, but sometimes.
Just a moment. Give me a minute. Just give me a moment. Now, am I audible properly?
Yes.
Audible? No.
It's breaking, is it? Yeah.
No, I was not speaking in written, but now is it audible? Are you able to hear me properly?
Yes, sir. Now it's fine.
It's fine. Okay. So what I explained about the green, red, and yellow. And I suggested that green color cell in technical term is known as concordant, the red color is known as discordant, and yellow color is known as tight. So I hope that definition is clear. These are the 3 behaviors: concordant, discordant, and tight. Okay. For model, concordant is good, discordant is bad, and tight is neither good nor bad. Now, when we calculate the concordance percentage, how this percentage is calculated, if you look at this cell, all the colored cell, we have 21 cells. Out of that, 19 are green. Out of 21, 19 are green. So if you have calculated the percentage, your percentage will be is equal to 19 divided by 21. That is going to be close to 90%, 90.4%. So this is what your concordant pair is given. But what is the percentage of concordance? Is that clear? Now, then coming to discordant. Similarly, we have one red cell with respect to 21 cells. So if I calculate is equal to 1 divided by 21, this is what 4.7% we are getting discordant pair. And similarly, similar is going for tight pair. Is it fine? So we calculated concordant pair, discordant pair, and tight pair. Now, after that, there are certain statistics that you need to perform. So there is a term called Somers D, the way I have written it. Somers D. This Somers D is calculated as difference of concordance and discordant. This is what the formula is. Concordance minus discordant. That is concordance percentage minus discordant percentage. In our data, concordance percentage is 90 and discordant percentage is 4.76. So if you take the difference, you are getting this 0.85. So this 0.85, this value, this is how Somers D is calculated. So this is the parameter. I would say that is an indicator that how good or bad your model is. Higher the value of Somers D, better the model. Is that clear? Is this calculation clear to everyone?
Yes.
After Somers D,
Sir,
yeah.
sir, we are actually calculating on actual values. So we test on predicted values.
This one.
Yeah, this model.
This
for knowing that.
We only calculate on predicted value. We never calculate on actual.
Okay. Okay, sir. I thought you are doing on actual.
No. After that, there is another term which is called gamma. So gamma is calculated like concordance minus discordant divided by concordance plus discordant. So it is extended version of Somers D. So according to Somers D, the concordance minus discordant is, that's how Somers D calculated. Then gamma is calculated like concordance minus discordant divided by concordance plus discordant. So these two parameters you need to remember. People sometimes ask in technical round that what is Somers D, what is gamma, what is concordance, discordant, right? I hope you people are clear about the calculations.
Yes.
Now,
So which one we need to consider, either Somers D or gamma?
that's a good question. I will give you some idea at what happens. So let's say that in your model you have concordance. Let's say your concordance is having 90% and your discordant is having 10% and tide is having 0%. That is possible. Think that this first scenario. Second scenario is we have your concordance is having 5%, discordant is having 5%, and tide is having 5%. Let's see what is happening. Let's first calculate so much less. It will be like 90 minus 10, which is going to be 80. That is 80%. Okay, these are all coming in terms of percent. So much D. Then calculate gamma. Gamma will be 90 minus 10 divided by D plus 10. So it will be 80 divided by 100. That will again give you 80%. Getting that? So much D and gamma both the same. There is no tight pair. But if there is tight pair, then value will change. Like this case, your S of D is going to be 90 minus 5, that is 85%. But gamma is going to be 90 minus 5 divided by 90 plus 5. So it is going to be 90 divided by 9, which is not equal to 0.85. So if there is tight pair, that is gamma is used.
will be
It will be
85.
It will be 85 by 9.
sorry, sorry, 85 by 90. Correct. This will be 85 by 90. That is again not equal to 85%. So in your data, you have some tight pairs, then go for gamma. If there is no tight, then gamma and SOC both will give you the same result. I hope now you got it.
Yes, sir.
Now, but I would say there is so much the gamma confidence. These are all information you get on inside LSS, not in R, not in Python. You need to calculate it by writing some command, writing some functions. These are not default option. It is good to know, but it is not a default option. So now I'm going to recap that what all we discussed, learn in the last 45 minutes. So we discussed about likelihood, then deviance, then we discussed about AIC, BAC, then we discussed about concordance, discordance, right, Summers D, and gamma. That's what we discussed. So these are the matrices which are there in logistic regression and must know the meaning, interpretation, role, etc. That's fine. Now, as I mentioned, this is the most important topic, so we need to be careful in the same context. This was discussed in the previous class, and I explained this is how we write the. I explained about the maximum log likelihood. In mathematical representation, it is written like this way. I would suggest to remember the formula which I wrote. Reason being, this formula may create some issue for you in terms of remembering it. But this is conveying the same message. It is the same one. I wrote like how this formula is written. If I make the comparison, wait, I think. So the formula which I wrote, that is the easy one, I would say, like your y log pi plus 1 minus y log 1 minus py. That's what it. In the mathematical way, people write like this is indicator of real number and say that probability of is equal to 1 plus 1 minus p. Again, writing this one. This question is written anyway. 1 minus p, wherein y is going to be 1. So that is written in this way. So in one case, you will be getting p. That is the equation it is written. Yeah, in one case, you will be getting p. In another case, you will be getting 1 minus v. This is short form of the previous way I wrote. So look here. It is. This p is talking about, it is only in the notation, it only writes this part, which is inside log, in the notation. The actual formula is the above one which I wrote. So I suggest you to remember the above formula which I wrote, because that is easy for you to explain. That's given here. Now go to, in linear regression, we use some of this required error term. In logistic regression, we need to maximize the likelihood. That is the log likelihood. That's what I explained. That this is what our objective function is going to be. So our objective is to maximize the value of log likelihood. I hope this is fine. Is it clear?
Yes.
No. Then something is written. Just go through all 4 tiles and tell me your understanding. What do you mean by it? Is it clear?
Dummy code in the third one.
Come to the third one.
Dummy code, the third one. What does that stand for?
I will explain about dummy code is what I dummy is one hot coding I explained in the earlier regression. So one hot coding, yes, one hot coding is a name which is coined in Python, but technical name for that is dummy code. Yeah.
So dummy code is basically like divide the factors like in factors.
Yes, we need to create many and many labels. I hope that's fine.
Yes.
Okay. With that, at 6:30, let's have a break, and we'll continue the remaining slides post break.
Yeah.
Yes.
So 6:30, try to come by 6:45.
Yes, profit or spend 30 fucking loan cash. That's over.
Hi all.
Chinmay.
Please ping in the chat. I wanted to know how many people are back. Just say yes.
Chinmay, if possible, due to Wi-Fi issues, I couldn't actually hear when you were showing about how you selected the concordant values. Could you just show that matrix once again, if possible?
And that I will show. Is it visible?
Yeah, it is visible. Can you? Yeah. How did you actually select which were concordant?
So in the 10 cases, the cases we have 1 in actual, that is given in the row. So like 167. 167 are 1. Okay.
Yep. Okay.
And the remaining are given in.
Yep.
Fine. Then we're comparing the probability, the predicted probability of 1 and 2. This set is talking about 1 and 2. So if the predicted probability of row is higher than the predicted probability of column, we are coloring that as green.
That means 1 is higher than 0.06, 0.6.
Yes, so 0.6 is higher than 0.1. So predicted probability for case number 1 is 0.6 and for case number 2 is 0.1. That's fine.
Okay.
That's how we are comparing.
This 0.6 is greater than 0.6.
Yes, so that's why we are writing here green. So if your row probability is higher than the column probability, right, put that as green. If it is reverse, put that as red. If both are the same, then put that as a yellow.
Okay. Got it.
And then we are counting that out of total number. How many are green, how many are red, and how many are.
Yeah, that I could figure out.
And then coming to slide, this is what we are talking. Slide. And then coming to next one. So this is what it's given per parameter. We discuss about deviance. The R square is used in linear regression, not in logistic regression. In logistic regression, there are reason to calculate something called pseudo R square. It is pseudo, not the actual one, which are not the correct way to calculate. So technically, there is no R square in logistic regression. We calculate the coefficient and the p-value the way we calculated in logistic regression. So in linear regression, for each and every variable, we had coefficient and we had p-value. We discuss about key information criteria AIC. Then G index will come later in the decision tree. So that is part of the decision tree. I will explain that in future. There is something called Fisher information criteria. Fisher. So that is given in the slide. The moment that slide come, I will explain there because merely saying theory won't help. We are going to talk about something called confusion matrix. That is one of the way to do the model evaluation. And ROC curve, that is the receiver operator characteristics. This will talk going forward. Sensitivity and specificity, again, I will explain going forward. And there is something called HL test, that is osmolar goodness of fit. So these are certain files that I will talk later the moment I proceed into the next set of slides. But here, what all we discussed on date, that is deviance, coefficient we know, and a key information criteria AIG. So these are the 3 things we are aware. Fine. The remaining will see going forward.
Right.
Now, here something is written for variance. just go through and say your understanding that what you mean by these four informations. Is there a question on these four types?
So what is null deviance?
Yes, I will explain that. So look at the way how this model is written. So I said that the pure consider two scenario. Scenario number one, wherein your probability is calculated like 1 divided by 1 plus e to the power beta naught plus beta 1x. This is scenario 1. Scenario 2 is wherein we are saying that your probability is going to look like 1 divided by 1 plus e to the power only beta naught. This is the second scenario. In second scenario, we are not considering any independent variable. That means it is only this beta naught is what is the intercept. If you look at the y is equal to mx plus c, this is the intercept. So technically, this is what the beta naught is only intercept. So a model which does not consider any independent variable, that means there is only the intercept value, and using that intercept value, you are getting model, and for that model, the moment you get the deviance, that is known as null deviance. So if you are going to use this model and calculating the deviance, this will be termed as null deviance. Is that
Clear.
but the moment you are adding independent variable, so that becomes residual deviance. Getting it? That means by theory itself, a model with independent variable is supposed to be a better model without independent variable. So I'm saying the first scenario, first model is supposed to be a better model than the second model, because in the first model you are having independent variables. Is that clear? So this second case, the deviance which is calculated here is called the null deviance, and if you calculate deviance from the first scenario, that is known as residual deviance. This is name of deviance. So deviance, I think the first way, if you calculate the first way, that is known as residual deviance. The second way is known as deviance. Now, as I mentioned, the first accuracy which comes from the first model will be better than the accuracy coming from the second model. That means your deviance for the first model is going to be lesser than the deviance for the second model. Is that clear? I hope I'm not confusing you all. Is it clear what I explained?
Trying to see.
I didn't listen. There was some background noise. So you were saying something?
I said trying to see this.
Can my low deviance means it's better, and here in the first scenario, residual deviance will be lower.
Yes.
So that is good, right?
Yes.
So that's why we prefer the first
Yes.
way. Okay.
So when we compare the model, first of all, there is something called baseline. In every model, you remember in linear regression, I suggested baseline in the model which is coming by help of average number. Here in logistic regression also, your baseline model is the model which null deviates. That means without any independent variable. After that, if you keep adding independent variable, the objective is to increase the model accuracy. That means decrease the errors. That's fine. That's why your residual deviance value is always supposed to be lower than the null deviance value. Then only model is improving. Otherwise, model is not improving. Is that clear?
Right.
Now read the slide and try to make out the meaning from here. Give me a moment. In a minute or two, I will be back. There are some this. I need to set my power plug. Just give me a moment. I think now this is clear. This slide is clear to everyone.
Yes.
Yes.
Okay. Now, coming to next one, as I suggested that there are something called pseudo R square for logistic regression. The way this name is suggesting pseudo means something which is which approximates the way we calculate R square. And in data science, there are 5 pseudo R squares. Manfredon, Naglers, Cox and Snell. Likewise, there are 2 more. Fine. Now, unfortunately, there are different people who suggested certain method to calculate R square for logistic regression. Unfortunately, none of these pseudo R square value match with each other. So if you're going to calculate Manfredon value or Naglers or Cox and Snell, this value never match with each other. So that is another reason that this pseudo R square is not considered in the industry. It is good from the academic perspective, but we are learning we are learning the applied data science. So in applied data science, pseudo R square is never used. You will hardly getting any video or any material wherein people talk about pseudo R square. It is good to know, but it is never used in any data science project for any kind of validation. Reason is none of these pseudo R square value match to each other. It is good to know, but we are not going to use anywhere. You will not be getting any code written for the pseudo R square. The reason being, your pseudo R square value exceed 1. So the way the mathematical formulation is given, this mathematical formulation give you R square value is more than 1, which we never buy it. You should not trust the model. That's what it's saying, that it should R square something. So it is like completely dubious. So just ignore it. It is good that it's given in the slide, but I'm going to ignore it. Now, next is at the p-value. So the application or interpretation of p-value happens in the same way, the way we did for in the linear regression. So there also we set some hypothesis and then we reject or we fail to reject. So technically, this right side is your rejection region, and the moment we get if the p-value is less than 0.05, so that goes in favor of alternate hypothesis. So it is exactly the same. We're discussing linear regression, nothing new. Then here something is written for Akiki information criteria, AIC. It is the same definition, same equation which I wrote. Just go through and then share your understanding. I think it's fine. I hope you are getting the meaning.
Yes.
It is at the bottom, the last tile is saying that if you have more than one similar candidate model, that means the competitive model, then you should select the model that has the smallest AIC. That's what he said. They said that low value of AIC is good for the model.
Chinmay, that part I couldn't get exactly.
It is saying that unlike just the number itself is not meaningful. So here, the AIC number standalone is not meaningful. It only helps you to compare two values. If you have only one model and you are getting some AIC value, you won't be getting any meaning from it. It helps us to do some comparison, nothing else.
Right.
Got it?
Yes.
Now I hope this is clear. I hope this slide is clear to everyone.
Yes.
Now, then there is something called Gini coefficient. And Gini coefficient I will explain in detail going forward. Reason being, it is something like the story of that what happened first. It's like circle. So, and for that I need to explain AUC, that is area under curve. So let me first complete this AUC, then I will come back to Gini value. That's how Gini is calculated. Because Gini and AUC both are new for you. So first I need to calculate. First I need to complete Gini AUC, then I will come to Gini. I'm just parking it for time being. The next is feature information criteria, and this is the optimization process on top of your algorithm, which help your machine to optimize the process in a in a in a very small iteration. So feature suggested certain optimization. This is for optimization, nothing for the model. So it is more like for your machine. I will going forward in a decision tree. I will explain more about the progression, that how from one model to other model or from one step to other step, how things move. So in that context, features suggested certain process, and according to each process, technically your model is supposed to convert into between 4 to 8 iterations. So listen very carefully, because this is all like theoretical. We are not going to discuss any equation, because this is not part of the logistic regression equation. This is more from machine perspective, that how your machine is going to work when this algorithm is going to process. So this is known as the feature information criteria. This is optimization technique. Here, the first style is talking about it, optimization procedure. So this is the optimization technique. So features suggested certain way that which help machine learning algorithm to optimize or logistic regression between 4 to 8 iteration. That's what he suggested. So according to in majority of the cases, what we realize that close to 5 or 6 iteration, your model gets optimized. So this does not really tell you a lot that you need to know, other than the fact that the model converges or not. It only gives you information that your model has converged or your model has not converged. What is the meaning of converge here? The meaning of converge here is that is your model is able to find the best value, or the model is not able to find the best value. That is what meaning of converge is. So it only gives you information that is it. Let's say that in machine learning, what happened? Things happen in iteration, multiple iterations, and let's say that your machine is the process is not optimized in a way wherein in the few initial iteration it try to get the best result. In that case, it will start into infinite loop. So the way the programming is done or the package is written, people consider the guideline that is given by feature to optimize it. So it is more for optimization. That's what your first line is saying, that you only need to know that your model is converged or not. Beyond that, nothing is required. Now, the first, then the second line is saying that number is typically in the range of 4 to 8 and convergence diagnostic. So with 4 to 8 it converges. If you see here, the graph itself is saying that technically close to 4 5, majority of the convergence happen, but beyond 8 is very rare chance that something else is going to happen. The first is if the optimization procedure that are used to train the logistic model has not converged, we expect the number to be high. So in that case, if your model is not converged by R, you will be getting information like the feature iteration. If you are getting that your feature iteration number is more than 8, that means your system is not able to converge it. That means the model that you are getting, that is not the best model. I hope you are getting what I'm saying.
So it's completely trained data we will able to optimize this.
No, I'm saying we need to optimize it. So it so happens that when you train your model, it is all about the framework, how the framework is set. Is your framework is able to optimize? That means is it able to find the best beta, or it is not able to find best beta? That information we get by help of the feature information. So if you are getting that your feature information is more than 8, so in that case your machine is not able to converge your model. That means it is not able to get the best beta values. That means
we cannot solve this problem.
No, the only requirement is increasing the power of the machine. Get the more powerful machine. Why I'm saying, when we run the same model on CPU and when we run on the parallel computing using big data, Hadoop or the other cluster, normally in CPU it takes some 5 to 6 iterations. But the moment we run on the integrated or the connected platform, in 1 or 2 iterations things get resolved. So it is more like your system, how capable your system is to optimize. Reason being, equation, everything is the same. It's more about calculation.
This applies only for the logistic regression model.
There are certain other places wherever this binary split happens, the feature information criteria comes. But this is more appropriate for binary classification in logistic regression. So yes, I can say feature information criteria is more pertinent in case of logistic regression. And going forward,
And when we are running into powerful,
yeah, tell me.
When we are running into powerful, it uses same algorithm which our computer uses, or it uses different algorithm.
It is the same algorithm. The main package is the same. It is more about the kind of platform that is given.
Right.
And the moment I talk about support vector machine or XGBoost, there will come to know that why this convergence happened. Because the way machine learning algorithm converts it into the background, it runs something called differential equation. Getting it? So for differential equation, it needs to converge. The derivative, multiple derivatives side. I will quickly showcase. Just give me a moment. I hope you will be just on tentative, I think, because I don't want to go in detail. Wait. You can see here what is happening. This is just the interpretation that what is happening. You may see a lot of to and fro communication happening. Like first it is moving from left to right. Wait. First it is moving from left to right. See the arrow. It is moving from left to right. After that it is moving from right to left. Getting that. So a lot of to and fro communications happen. That's how your system tries to optimize. Look here, they are all errors. Actual predicted value. It tries to optimize. Getting that? So in that optimization, how many iterations it is going to have, that's what information we get in feature information criteria. Fine. So it is only the numbers. The moment I run the model, I will point out that where this feature information value is coming. Something close to 5 is good. Then coming to something called confusion matrix. So wait, I think for confusion matrix, I created something. Let me land to Excel. Then I will explain about the confusion matrix. So this is going Excel, and this is going predicted. And I'm saying good, and here I'm saying bad. Here also I'm saying good, and here I'm saying bad. So let me do some formatting to get that in a proper way. So look at the scenario, and this scenario is talking about the case. Let's say that we are going to talk about good and bad customers. So let's talk about the first cell. A customer is actually good. So my row is talking about actual, and column is about predicted. So a customer is really actually a good customer, and my prediction is also saying good. So this is going to be a kind of true prediction. Yes or no? I'm talking about this.
Yes.
Now, then a customer is actually good, but I'm saying as bad. So it is false prediction. Fine.
Yes.
The third says a customer is bad, I'm saying good. Again says at the place of false, it is going to say incorrect. So this is again so at the place of true, let's say correct. That will give you. Now think about the fourth cell. What is going with the fourth? Which I have not written. It is incorrect or correct? It is correct. Perfect. So this is what we do. So the way we create this matrix is known as confusion matrix. That's what the technical name for this matrix. Fine. And
Gentlemen, we have type 1 error, type 2 error, incorrect predictions.
yes. So we'll talk about type 1, type 2 error. Okay. Now,
Hypothesis.
yeah, you say something?
I think we covered this in hypothesis as well.
Yes. This covered in hypothesis testing. This matrix is known as confusion matrix. Okay. In logistic regression, this is what the matrix to calculate your model accuracy. So how model accuracy is calculated? So if I say that as A and I'm saying that other cell as B and this is going as C and this is going as D. So your accuracy is calculated as is equal to A plus D divided by A plus B plus C plus D. This is how the model accuracy is calculated. That means correct prediction divided by total number of predictions. I hope this is clear. Now, from here, I'm moving into slightly complicated scenario. So look at this case. Here, I am saying that my row is going to be predicted and column is going to be actual. Okay. And at a place of good and bad, I'm writing positive and negative. Like good customer, bad customer. So positive may be good customer, negative may be a bad customer. And here also for positive, that is a good customer, and negative, bad customer. Okay. So if you look at the first cell wherein I'm saying true positive, that is my true case. Why I'm calling it true positive? Reason being, in prediction, it is positive. In actual also, this is positive. So we're calling it as the true positive. Fine. Then look at the fourth cell. We are calling it true negative. Reason being, in prediction, this is negative. In actual also, this is negative. So your both the diagonals are true. So the green one is called true positive, and the yellow one is called true negative. And the off diagonals, which are incorrect predictions, we are calling it, this is term as false positive, the second value, and third value is term as false negative. I hope the first calculation is, the first part is clear.
So not clear, sir. Can you explain?
The same one that I explained. It is the first cell is where in prediction also that is true, in actual also that is true. This is the true case. It is the same one. The way it clear.
Yes, sir. Clear.
Then if you look at the second cell, false positive. We are actually this is negative, but we are predicting that as a positive. So this is called a false positive. This is what name is given for all these four cells. I suggested I say that your diagonals are true and your off diagonals are false. But there is in false also there is name like false positive and false negative. And it is denoted as like GP true positive, FP false positive, TN FN false negative, and TN negative. So these are names for these four cells. I hope this is clear.
Clear.
Now, then there is a term which is known as sensitivity. So it is known as sensitivity. At the same time, this is also known as recall. So both names, this is known by both the names. People call it hit rate. This is calculated as true positive divided by true positive plus false negative. This is how the sensitivity is calculated. So this is the equation or this is formulation to calculate the sensitivity. So sensitivity is calculated like true positive divided by true positive plus false negative. So either you call sensitivity, you call it recall, or you call it hit rate. All three are same. So in line item 1, what all I have written is all three are same. Sensitivity, recall, or hit rate. An equation is given how the hit rate is calculated or sensitivity is calculated, true positive divided by true positive plus false negative. There is another matrix which talks about a true positive rate, that TPR. How true positive rate is calculated? True positive divided by the total positive. So total positive is going to be the number we are going to add. That's what your total positive is.
Which number? Sorry, I didn't get.
The total
positive.
The true positive is given as
actual one.
Actual ones, yes. So in actual ones, what all positive are there? This is two. True positive plus false negative. That is what is known as the total positive.
Okay. I have to take actual one for the positive.
Yes. Clear?
Yes.
I hope this is clear to everyone.
Yeah.
Okay. Now the next is coming as sensitivity, so specificity. So that is specificity also known as selectivity. So there are many names for that. Okay. Look at the formula, how this is calculated. So let me do one change. This P is your real positive, which is given in the data, and N is a real negative. So I'm just doing that so that you do not get confusion at how to calculate this positive. Real, but that means actual. Then coming to specificity, people also call that as selectivity. It is people also call it that true negative rate. This is DNR. It is calculated like wait. So there is something moving here and there. That is the challenge with true negative rate. Let me put here thing that is the that is fine. Now it is fine. That comes from left to right. So specificity or selectivity is calculated like true negative divided by true negative plus false positive. And there is another term that is called true negative rate. The way we calculated true positive rate, in similar way we calculate true negative rate. After these two, the third calculation is precision. This is again very important. You see, I color like recall and precision in same color because these are like two faces of the coin, two sides. So how precision is calculated, that is given here. This is also known as a positive predicted value. People call it PPV, and this is how precision is calculated. Like your true positive divided by true positive plus false positive. So in technical round, people ask question about recall and precision. How recall and how precision is calculated.
And we are actual positive and negative values in the data set, right?
Yes, we know. In data set, we know that what is actual. That's what given to us. I hope it is fine.
Yes.
Precision is clear. Then coming to 4 is balanced accuracy. That is another term people call it. So balanced accuracy is technically your true positive rate plus true negative rate divided by 2. The one which we calculate. I calculate true positive rate, I calculate true negative rate. And when we divide by 2, that is known as balanced accuracy. The last one is F1 score. It is calculated like 2 multiply precision multiply recall divided by precision plus recall. And that is also known as harmonic mean. So F1 score is also known as harmonic mean. Now, homework for you people is to go to Wikipedia and in Wikipedia search like confusion matrix Wikipedia. Okay, I hope spelling is correct. Yeah, just click on first part. You will be getting a very decent right about confusion matrix. All term like the positive rate, saying that the number of the real positive cases in data. That means one. That's a positive rate. The negative rate, the negative value, that is the number of negative cases in the data. And saying that what is true positive, true negative, false positive, false negative, and all equations are given here. It is calculated. That is one thing. If you come down, there is a very good. This page is ultimate page, wherein it is saying that this is your predicted condition and this is your true condition, and it is putting into a framework: true positive, true negative, false positive, false negative. Look at type 1 error, type 2 error, and calculating this prevalence, what is accuracy, wait, what is the positive predicted value PPV, that is also known as precision. Then you're getting your negative predicted value, like your reference score, everything is given at one place. Getting it? So this part will give you very clear picture about all the discussed metrics, the calculation that what all we discussed. So it's your call. But I would say that if you spend some time on Wikipedia, here it is done a very nice detailing. Everything. It's hardly 10 minutes. I think post this class, you people can go through and you can understand what all is given here. My slide is also saying the same story, but in PDF page, it is given like it is more informative, seeing colors, everything. So these 4 5 informations I would say, like your recall, precision, F1 score. These you need to remember that how the calculation happens. I hope this is clear.
Right.
Yes.
Now, this is what the confusion matrix is talking about. Look, it is also saying that the first cell is going to be true positive, fourth cell is going to be true negative. The second cell is your like here the false positive from top to like the third one. So it is conveying the same story the way we saw even on the Wikipedia page. Then there is something called ROC curve, that is receiver operating characteristics. That's a curve that is known as ROC. This is another matrix in logistic regression to evaluate how good or bad your model is. And it is plotted between false positive rate and true positive rate. So this plot is done on these two axes, false positive rate, the way we just saw, and how it is calculated, and the true positive rate. And we plot in these two on these two axes. This false positive rate is also known as 100 minus specificity, and true positive rate for that another name is sensitivity. So true positive rate is also known as sensitivity. That's what I explain as well. Now, the best part of this RC curve is it is indicator of your model accuracy, how accurate your model is. And we calculate the area under curve. So the area which is there inside this curve, that is blue line, bigger the area, better the model. So if AUC, ROC, that is area under receiver operator characteristic curve is high, that is indicator of good model. Getting that? This bigger and bigger, this green line, the blue line goes up and up, the model will be better and better. Now, for a very poor model, I would say for the baseline model, it line goes like diagonal. Diagonal means 50%. So like because you have true and false, only two cases. So by default you say like 50-50 probability. So this dotted line is talking about if you consider the area which is downside of the dotted line is 50%. Getting it? So we should try to have a model which is as far as possible away from the dotted line on the opposite. If your blue line is going like from this place where my currently cursor is, if it's going like this, that's going to be the best scenario for me. Like if my model is going like this, that will be the best scenario. That is the best model for me. I hope that's clear.
Yes.
Now, some write-up is given in the 4 tiles. Try to understand what this write-up is saying. I hope this is clear.
Yes.
In my first point, why is it saying trade-off between sensitivity and specificity? Because we are not looking at.
No, reason being this is plotted between sensitivity and specificity. Your one X is sensitivity, other X is specificity. That's why it is saying that trade-off.
No, the other one is not specificity. Specificity is a two negative rate.
No, here if you see in the graph, are you getting your X-axis is 100 minus specificity? That means it is calculated by help of specificity. If you look at Y-axis, it's sensitivity.
Yeah, there is a relation between false positive rate and specificity. 100 minus specificity is equal to false positive rate.
Correct. So it is plotted between these considering sensitivity and specificity. That's why it is saying there is trade-off.
Right, right.
I hope this is clear for others as well. Now, then the next is those are all calculations like sensitivity, specificity, how it is calculated. PPV is your predicted positive predicted value, NPV is negative predicted value. So the same one, the matrix which I saw, it is coming from there only. Nothing is new. This is what I explained. And here some further write-up is given. Just go through that what this story is saying. If you realize this screenshot is coming from Wikipedia page only, isn't it? So it is coming from there itself. Here source is also given. Yeah. Just go through and try to understand.
I got it in my.
I hope it is clear for others as well.
Clear.
Yes.
Yes.
Now, then there's another test that talks about the HL test, that is Hosmer Lomoso goodness of fit. Let me tell you one thing. There is some drawback in this test. This test only gives you information that your model is good at the overall level or it is not good at the overall level. The way we saw the F statistics in linear regression, we saw the F value. F value says that overall your model is good or your model is not good. That's what I explained when I was talking about F value. Correct?
Yes.
In linear regression, the F value only indicates that how good or bad the model is. The similar to F value here is SL test, that is Hosmer-Alonso goodness of it. It says that your model is good or your model is not good. The problem with this test is it never tell you that if your model is not good, how to make it good. That information is not here. So it is like critics half-baked. So people feel very hesitant to use it because if a model is not good, they do not get to know that how to improve it. So in that case, they need to depend on other models. Like for classification, people use random forest or tree-based algorithm or something else because its actual test never give information how to improve it, and that is not written here. So go through all the bullets, you will getting the same information. First, go through, and I will explain if you have any concern or any doubt.
Chinmay, we got it. I think.
It is clear for others as well.
Yes, Chinmay.
Yes, Chinmay, clear.
Okay. Now,
Chinmay, can you explain last point?
last one, second last or last?
Second last.
Second last.
Second
And
last.
okay, it's saying that as the measure of the model fit, use this as just one piece of information in deciding how well this model fit. That's what I mentioned. You can understand, you can check that your model is good fit or it is not good fit. It does not work well in a very large or very small data set, but it is often useful in other scenarios. So your data is very big or your data is very small, it does not fit well. That's why it's the only precaution about Excel test. That was the reason I said that is something called half baked. It is not a finished product. It won't answer if the data is very small, it is not useful. If data is very big, it's not useful. It never says that we all are the improvement area. So this is something which needs kind of further fine tuning or further R&D on top of this.
That means it's used only for the test data or train data, which is actually a sample data
It is
of the last data set or something like that.
Yeah, so it is not useful on use on a big quantum of data.
Got it, Chinmay.
Now, then coming to next slide, that is event rate. Okay. Now, if you before I jump to event rate, I wanted to write that equation, probability equation in a different way. So as I suggested that your probability is written like is 1 divided by 1 plus e to the power beta naught plus beta 1x. That's how it is written with a negative sign. Okay. Then slight modification, I would say a better way to write this equation is written like probability of y being 1 given x is 1 divided by 1 plus e to the power beta naught plus beta 1x. That is how the better refined way of writing the equations. So the same above equation, if you want to write in a more explainable way, this is the way how you will write. That means this equation only calculates the probability of something being passing the value of x. Like when you're passing the value of independent variable, it calculates the probability of something being 1. If the probability of something being 1 is very small, let's say 10%, then probability of something being not 1 is 90%. I hope you're getting what I'm saying. Is that clear?
Could you please repeat, Chinmay?
I said that initially when I started logistic regression, I said that this equation, the way we calculate the probability, we calculate the probability of something being 1. What is the probability that a case is going to be 1? That means a good customer or bad customer. It depends on how your level. So this equation help you to calculate that what is the probability of something being 1. Let's say first case. I'm writing first case. Let's say the probability of first case being 1 is, let's say 0.2. So I'm saying probability of first case being 1.2. Then probability of 0 will be 0.8. 1 plus probability of 1 will be probability of not 1. Is that clear?
It's clear.
So this is the better way to write the equation. We say that probability of y being 1 given x. That's what.
Go to the में थोड़ा सा. राज में here.
I hope that is fine.
बाहर बड़ी है सब्जी है.
I hope that is audible to everyone. People, guys, you need to be mindful for others. If you want to do some talk, please mute yourself and then do it. Now, I hope this equation is clear. Now, the same is given here. The same is given here. It is saying the event rate. So, in our case, what is event rate? Event rate is the rate, a percentage of 1 in your data. Saying that event rate is statistical term that describe how often an event occurs. One event occurs, that means how often people are defaulted. So if being default is an event, you are going to calculate the probability. So that is known as event rate. It is in that divide the number of times the occurrence happened by the total times that occurrence could happen to determine the event rate. In your data, if let's say there are 100 cases, out of that, let's say you have 100 customer information, out of that 30 customers are defaulted, so your event rate is going to be 30 divided by 100, that is 30%. Now read both the tiles. I hope now it is clear.
Yes.
Now, there is something called weight of evidence. This weight of evidence is calculated like percentage of non-event divided by percentage of event. So non-event is percentage of good event, percentage of good customer divided by the percentage of event, like percentage of the bad customers. That is calculated as weight of evidence. This is a term which is used for further work that will come later. I hope this is clear.
Yes.
It's simply calculation. Now, it is saying that what are the steps to calculate weight of evidence? We know we need to first calculate the number of event and non-event, then calculate the percentage of events and non-event, and calculate weight of evidence by doing the division. That's what the step is written. Just go through. I think it is fine. It is just simply saying that steps. That what are the steps involved.
Yeah, right, Chinmay.
Here, something called information value. Another, which is calculated like difference of non-event and event multiplied by weight of evidence. And this is very useful information for us. That is information value, which says that your data is sufficient or data is not sufficient for prediction. So this is the formula: percentage of non-event minus percentage of event. First calculate that and then multiply with weight of evidence. If the value of information value is less than 0.02, then your data is not useful. You won't be able to generate any insight. If the information value is between 0.02 to 0.1, you will be getting a weak predictive model. You won't be getting a very good model. If value is falling between plus 1 to plus 0.1 to 0.3, it will be a medium predictive power. If something between 0.3 to 0.5 will help you to get a strong model. But if something is more than 0.5, then your model will be very, very suspicious. That means that won't be a very stable model. So the desired requirement is that you must get a data wherein your information value is going to fall between 0.3 to 0.5. That is how we decide the data given to us is sufficient for analysis or that is not sufficient for analysis. I think we are getting the meaning. So
for binary or
no, for binary. It is only for binary.
okay.
Then I explain about concordant, discordant, tied. Those all informations are written. Just go through, try to understand. You have idea how concordant, discordant, tied is calculated. Something is written on that part only. Just go through. I hope this is clear.
Yes.
So these are different information that is given, and we need to be careful. If you take my opinion, we do not use everything. There are some handful, I say, handpick of the certain informations that we use. As I mentioned, we use like your confusion matrix. Then in confusion matrix, we calculate the accuracy, sensitivity, specificity. Those are the information. Then concordance, discordant, tied, and C statistics. This information comes in SAS by default, not in R and Python. In R and Python, you need to write specific code to get this information. It is good to know, but do not spend much time in order to remember this all. Yes, you must be in a position to answer if someone is saying what is concordant, what is discordant. But in R and Python, we rarely get this matrix come as output without putting some extra effort. Fine? I hope it is clear to everyone.
Yes.
Now, let me move to next slide. Okay. Now, it so happened that when your data is given to you, and in that data, the event class is very small. Let's take the example of what I say, the credit default. Or if you talk from the insurance industry perspective, so even in the insurance default, or I can say the insurance fraud, So there are very rare instances, like out of 1,000 cases, there is hardly 1 or 2 case, which is the fraud case. Getting? So it so happen that if I talk in real life scenario, these event rates are very small. It's very rare. In the typical scenario wherein people need to have some intervention. Now, it so happen in that cases, your model, let's say, I'm giving another example. If in your data, there are 5% only default cases, that means 95% are non-default cases. Like out of the 100 customers, 5 are bad customer, 95 are good customer. Okay. And let's say that you are given a new data of 100 customer and you need to predict that who is going to be defaulter, who is not going to defaulter. Okay. Let's say that without using any machine learning, you are saying that all these 100 customers are good customers. Fine. So in that case also, you will be 95% times correct, because in history, your good customers were close to 95%. So without using any machine learning algorithm, your accuracy will be 95%. Yes, sir.
Yes.
Now, so in that case, what is the need of the model? You are already getting 95%. Okay. Now, but still in those cases also we need to have model. Even you have 1% event rate, still you need to make a model. Now, so in order to counter those scenarios, there is something called SMOT, that is synthetic minority oversampling technique. So it's a technique which help you to do some oversampling. That means in your data, if you have only 5% of the event, then you can increase this event from 5% to 25%. That means you can create some new instances. That means in your data, you can do some simulation and you can increase the record of the event scenario, like the bad customers. And this is done by, this technique is known as, that's what I mentioned, that is synthetic minority oversampling technique. So it is a technique which help you to increase your event instances. And from that perspective, something is written in the previous slide here. Just go through. Now you will be getting the meaning. I hope this is clear.
Yes.
Now,
So upsample is done manually.
you can do upsampling manually, but manually there may be chance that you are not creating a good quality of sample. That's why we depend on this mode technique. You can, yes, essentially do. I remember 10 years back when there was no upsampling, like these techniques were not there. We used to do upsampling manually. Yes, you can do, but those are kind of suboptimal way.
Okay.
Now, so what SMOT does, look here, this is your original data, left hand side. And wherein, let's say that this circles are let's say event rate, and you are applying SMOT, that is this technique called synthetic minority oversampling technique. The moment you are going to apply this technique, see what this technique is doing. It is creating more and more circle instances. And if you see properly, these all circle instances newly created are very similar to the original data points. Getting that?
Yes.
So it simulates something wherein the new cases which are created, which are very similar to the existing cases. Otherwise, your model will not perform good. If machine is going to create something which is not similar to the real scenario, then your model will be in a big trouble. I hope that is fine.
Yes.
Chinmay, in this downsample, upsample is also happening along with oversampling.
I would say that first of all, the moment you are going to do downsampling only you do when you drop certain records. Getting it? So
Right.
the moment you are dropping some record, that means you are losing some information. Getting that?
Correct.
In upsampling, you are not losing anything.
You're increasing only the
Yes. So that's
variable.
why downsampling is, again, those were the technique 5-10 years back people used to work, do the downsampling. But in current context, downsampling is not ideal choice because we have faster computation system, we have better optimized algorithm. So in that case, why to go for downsampling?
Right. So we are using upsampling and making it oversample.
Correct. Until and unless this is not manageable, I think you need to ensure that do not increase the data points to certain extent which is not manageable by your system. So that is another I say caveat here.
Right.
And I hope this is the last slide. Yeah, that was the last slide. Okay. So with that, we are through with the theory of logistic regression. Okay, and as I mentioned that this is a kind of most important technique. So you need to be very, very careful about remembering the concepts. So from there, what my plan is, I am going to perform certain tasks on data and then see how this logistic regression is going to look like. Wait. So let me showcase the problem statement that will give you a fair idea. Just try to read the problem statement. I'm going to increase size so that it becomes proper readable. Just go through, try to understand. Once it is done, let me know. I will scroll down.
Chinmay, actually, as per what my understanding is, like in this statement, it is written we have to calculate the credit limit allowed to a person. But that will not be a logistic statement,
No,
problem
it
statement
is
then.
not credit limit. There is a label called good or bad customer, default customers.
Credibility of the customer.
Yes, that is
Yeah,
credibility.
but the problem statement is written differently. A system was in need to effectively decide the credit limit to be allowed to a person.
So they are
So credit
saying, so understand. So it is technically the moment you are going to talk about good and bad customer, that help them to decide indirect. I would say the answer that how this model is going to provide. It help the credit lender to decide that what money should he or she lend to others. If your model is saying that in the current limit that you are passing, these customers are going to be defaulted. So this information is given for the same limit of all the customers. So you are correct, but it is like in terms of solving the problem statement, it is giving information about the credit worthiness, that which customer is credit worthy, which customer is not credit worthy.
Okay, I think that can be used to define a second model we can create separately.
Right.
This is a separate formula.
Yes.
Okay.
I hope till here it is clear. Should I scroll down?
DM stands for
Which one?
status
DM.
of existing account. Yeah.
This is DM is it is talking for the day something. So it is how long. These are all like numbers. It is the bank term that how bank write information about. If someone is there from the banking background, they may understand. This is the banking term.
Okay.
Chinmay, would you please explain what is exactly that status of existing account?
Status of existing account, since how long someone's account is existing in the bank, like recently 0 to 200 days, more than 200 days, since how long someone's account is there into the bank. That's fine.
You can scroll down.
I think now it is clear.
Yes.
Credit amount, that what amount they are looking for. Again here, let's go through. I hope it is fine.
Yes.
Yes.
And then
I hope for others also that is done.
Yes.
Done.
Yeah, done.
Now, so that was like on the part of data understanding. Okay. Now, from there, I am landing to the place wherein we are going to read the data, and let me first showcase the data as well. This is bank credit. Okay. Wait, this is your bank credit data, where that is coming. So these are like customer ID, credit amount. These all informations are given to us. And if you see at the end, one information is given like the default payment, that 1 or 0. That is what the information given to us. Now, with that, I'm going to first read the data. So I'm saying read.csv, that bank credit I passed. If I open the data, this is how your data look like. That is perfect. Then if you look at the first variable, let me run the names of df underscore bank. The first name is coming as the customer ID. Do we need customer ID for the analysis? We need not it.
No.
So that is the reason that in line number 5, I am suggesting to drop it. So currently we have 25 variables. The moment I run it, it is going to be 24. Fine. That is perfect. After that, these call names and all not required. Let me run the structure str, and this is how the structure information is coming. Like we have the multiple stuff. This is given to us, and from here we are going to perform some task. Now, it is important for us, your dependent variable is default payment. So let's see how default payment is looking like. Like this is what the information is given, 010101. Getting that? You need to be very careful. Reason being, post completion of logistic regression, I will start something called tree-based algorithm, shade and cart, that does the same task, that solve the same objective the way logistic regression is doing. So you need to be careful that in which way the dependent variable is given here, because in case of tree-based algorithm, your dependent variable structure is going to change. So just wanted to sensitize here, because in your previous batch, people are struggling a lot to understand the difference, that why their model is not, they are not able to perform the task. That means why they are getting the error. So I just wanted to sensitize. Look here, it is looking like 0101. Fine.
Right.
Now, if you look at the table, the moment I run this table statement, see how it is saying. It is saying that in your data, there are close to 23,000 records which are 0 and close to 6,000 records which are 1. If you want to know the percentage, 1 is your event class. If you want to know the percentage of event class, it is 22%. So I would say that 22% event is good enough. We need to only do the oversampling when the event rate is less than 5%. That's what technically we do. If your event rate is coming like 20, even 15%, you are fine to go ahead. So here, no need to do any kind of oversampling. That is fine.
Yes.
Now, after that, let me run the structure. If I run the structure, you see what is happening. It is saying gender is integer. It is showing because the way data is given, it is given 1, 2. Fine. So in your data, someone has encrypted saying that like 1 is going for male and 2 is going for female. Likewise, that information is given. That does not mean that this 1 and 2 is a number. You need to convert that as a factor. Similarly, academic qualification, multiple level of academic qualifications given. So here those labels are given to us like 1, 2, 3, 4, 5, 6. Multiple labels are given. Marital status, again 1, 2, information is given. Age year, that is fine, but there are many variables which are categorical, but here that is looking as a number. So what I did here in the code, I first identified that which all are the variable. So these are the variables. Wait. According to me, which is supposed to be converted into the factor. These all variables: gender, academic qualification, marital status, repayment status, JAN, because repayment status is only yes, no, 0, 1. So all repayment status are like, it is not a number, those are indicators. Getting that? So what I did, I make a container saying this container name you can give whatever. I just wrote here for to give a proper meaning that what I'm doing here, but you are free to give any name. So I'm saying here the gender. So I'm creating this container here first, and after that I'm using this function called lapply. So I'm saying lapply, take my DF bank data and consider only these variables which I wrote above, and I want to convert that as a factor. So in one go, it will convert these all variables into the factor. Either you do one by one as not factored, getting the way it was done in the initial of the exercise, or you use this lapply function to convert all the variables in one go into the factors. I hope this is clear.
How many levels can a factor have maximum
There
we can
is,
consider?
see, in machine learning, your on a normal, like on your CPU, you can handle 52 labels. More than 52 is not handled by CPU. So maximum is 52.
Okay. So minimum?
Minimum anything more than 1.
Okay.
In your data, if you have only one label, that data is useless. If you have only male information, so what will you do with that gender? That gender is useless. So it is minimum 2, maximum is 52. Now, once I did that, I am running a function called lapply, and this lapply will convert everything into all the variables into factors. After that, if I run the structure, you will be getting this initial, these variables are like like let me see the gender, like gender, academic qualification, everything is converted into factor. That's fine.
Yes.
Now, after that, I'm going to do something which is slightly tedious, and I'm planning to cover that tomorrow, not today. So tomorrow I will complete this model building exercise using logistic regression, and we'll do some brainstorming. So the next task I will do tomorrow. I will share this code today in case you want to run something or you want to run along with me in tomorrow's class. That will help you to do that. That is fine.
Yeah, that's
Right.
fine.
Okay. We have a couple of minutes, 1-2 minutes. I wanted to talk about you need to be participative in terms of completing your project. So what all assignment is given, spend some time and come up with some solution, because whatever, right, wrong, whatever it is, do not come on the back foot. Otherwise, going forward, almost in every scenario, I'm going to give some case studies or some assignment. It will be like a breaking scenario for you. So participate, try to complete that case study. Those who didn't attempt for the previous, I would say the project. So try to attempt that, and if possible, come up with your solution tomorrow. I hope that is fine.
Yes, Chinmay.
Yes.
Yes.
Okay. So with that, I'm going to close here. Tomorrow we'll see you at 4:30, and then we'll do further deep dive.
Right.
Fine. So I'm closing it for today. Bye. See you tomorrow.
Yeah, thanks.
Bye. Thank you. Bye.